This unit on heat and energy lasted 16 days and was planned using data from the previous unit and research from education experts. After analyzing data from last unit, I saw that most students could successfully name and describe the three types of plate boundaries, which I taught by using hand motions. I used hand motions to teach kinetic and potential energy, as well as reteach the types of heat transfer. On exit slips, for days when I used hand motions, students could successfully define and explain these concepts in about 15 out of 22 exit slips. Students could also use these hand motions to give each other hints if a student forgot how something worked. Last unit, 13 out of 22 students gave a 4 on their learning target logs for being able to draw and diagram the layers of the earth. Because of this, in every lesson when I introduced a new vocabulary word, I had students draw a picture or diagram to explain that word, and this strategy was repeated with radiation. Students were very successful with the last unit compared to the others, as shown by their 79% average on the unit exam. Because of this, I related the unit to the material to the last unit. For example, in the station about convection, students had to describe how convection occurs in the Earth's mantle. In addition, students had to explain how energy movement shaped the surface of the Earth in my lesson on types of energy. The measurable student outcome was that students could define types of energy and explain how that energy is transferred from place to place. My unit cycle attempted to achieve this by including lessons that did not have long periods of lecture time and included many activities that students could do to practice their new knowledge. This included think pair shares, group demonstrations, reading and writing practices, as well as analyzing real-world applications. This defense will focus on students' ability to explain a movement of heat and convection and conduction during this unit. This learning target links up with California Science Standard 3C, which states that students will know that heat flows in solids by conduction and fluids by conduction and convection. I will be focusing on the progression of students from one period, and more specifically 5 target students that represent 5 generalizable types of students I teach. I used several math strategies supported by research to execute my unit lessons. In order to teach insulators, conductors, convection, and conduction, I used guided inquiry. For example, to learn conductors and insulators, I had students first feel the difference in heat of certain objects before students learned the concepts of insulators and conductors, as shown in this lab right here. Alright, this caused them to think about the topic for themselves before hearing the topic. Researchers such as Schwartz and Guicciarelli believe that this strategy helps students in K through 8 build on instructional ideas. I also incorporated experiments to build students' ability to analyze their own data. When students learned how to use a thermometer, they took temperature readings of 2 different amounts of water and had to use their data to decide about how much water had the highest temperature and how most thermal energy and other questions. This strategy not only gives students a chance to practice critical thinking with their own research, but also helps them remember material better, according to David Howery and Peter Riero. Although I was not always able to pull this off, I planned on having an exit slip every day to see if students met the objective, such as one right here where students could put down their ideas from that day and define concepts they have learned. This gives teachers and students alike the opportunity to find evidence that supports students' progression to mastery of the objective. Annotatsi and O'Callaghan note that exit slips work to put students' ideas into simple, coherent sentences that help them to reflect on their progress. The learning target logs, while meant to set expectations for student learning, were sadly not as effective as they could have been. Because this was the first time that I was doing this unit, I realized that I had placed more importance than needed on some aspects of the standards and less importance than needed on others. But while the learning target logs were not completely accurate, students still used them as a tool to gauge how they were doing and what they needed to study. Researchers such as MAST expert practitioner Clara Gary used these to help her students assess their own progress in class. I would now like to discuss my focus lesson on conductors and insulators. Because only about 5 out of 22 students could successfully tell me what conduction was, I took time to retake conduction at the beginning of this lesson. After retesting, I saw that 16 out of 22 students could write down a correct definition of conduction, so I decided to move into the lab process. After students had finished collecting data, students discussed the data until 15 out of 22 students were done with their discussions. When I transitioned into the guided notes portion, and after 21 out of 22 students gave me a thumbs up on if they understood conductors or insulators, I moved to the exit slip and helped the student that had an issue. As for my unit, I began introducing atoms and molecules from day 1. Because only 10 out of 22 students could successfully tell me about atoms and molecules, I stress these concepts more in the following week's lessons by forcing students to include these concepts in their answers. I then moved on to kinetic and potential energy. My 5 target students could successfully describe kinetic energy, but only 2 could define potential energy. Because of this, I had students complete an activity that included potential, kinetic, and the new concept of thermal energy. On exit slips, 4 target students could correctly describe thermal and kinetic energy, while only 2 could still describe potential. I then decided to reteach potential energy and temperature again in the next day before I introduced waves. As this was the end of the first 2 learning target logs, I had students take a formative assessment, which we then reviewed so that they could measure their progress. My advanced and average students did well on these exams, but the others did not, although all but one student, could define potential energy. Because in previous units 15 out of 22 students could define the types of heat transfer, I then decided to use stations as a review for students to relearn this material. However, only one of my target students could successfully define the type of heat transfer. Next year I will probably turn these stations into demonstrations to ensure that students are given proper attention to the definitions and descriptions rather than just the activity. I then had to reteach conduction on the insulator day and radiation on the emission day. Students then took a quiz to determine how well they learned the material from the last week. Because only my advanced and normal target students did well on the quiz, I gave my students 2 days to review before the test. Throughout the unit, my lower performer ELL and SPED students struggled with the material, which became apparent on the assessments because they all received lower than 60% on the grade. Next year and for the next unit, I must make sure that my lessons are sufficiently differentiated to facilitate learning for all types of students. My analysis of this unit gave me a lot of feedback about my next steps in developing as a teacher. Most importantly, I need to give clear, concise instructions that students understand. As of now, my instructions are often long-winded and confusing for students. For example, when I informed students of how to do the insulators and conductors lab, the activity took me a long time to explain and students were unsure of what to do or where to go. In surveys and interviews, 6 students explained to me that they are often confused about the instructions I give. I need to plan ways to give instructions in short and simple methods so that students can remember them and complete activities correctly. Including a piece of paper with all instructions on them would help students know what to do and follow the lessons better. This would save the class a lot of time that could then be used for teaching, practice, and clarifying questions. Many of my lessons did not include reflection on the learning target logs. I only used the learning target logs after we had supposedly completed a target, which means that we only used them 4 times during the unit. This did not give students enough opportunities to reflect on how well they were doing before the unit test. Because students only occasionally used the learning logs, they did not seem to understand how to use them. Many students gave 4s to targets that were not yet covered or seemingly filled out the learning targets randomly. Before the test, only 2 students who earned below B on the test came to me for extra help. I need to develop a progress reflection system that students understand they use frequently before formal assessments that affects their grade. This will help improve course mastery by the students. Because students have had success with using stickers or other symbols to track their progress, I believe this system would also be used with exit slip progress rather than learning logs, which students voice confusion and dislike about. In addition, I need to set up more experiences where students can collect and use their own data to understand concepts. For a science classroom, I have done too few labs to teach academic content. Because a third of my students explain that they learn better in labs, I should include more of these in the activities. However, I definitely need to keep a sizable amount of time devoted to lecturing, as 11 students indicated that they were most helped by direct instruction and active note-taking. This strategy would improve students' ability to apply their own knowledge and use critical thinking skills to come up with their own solutions to knowledge. Researcher Richard Paul notes that this is the most important type of learning that a classroom can provide because it creates higher-ordered thinking skills in students.